3 stories. This is the approximate height of the most colossal trucks ever constructed for industrial operations. These massive machines are engineered to execute extreme tasks and navigate terrains that are considered impossible for standard equipment. Why do engineers design vehicles that reach the scale of multi-story buildings? This choice is not a pursuit of aesthetics, but a technical necessity driven by the need to transport hundreds of tons of rock in a single cycle. Specialized suspension systems and reinforced frames allow these units to operate in climate conditions that surpass the endurance limits of most human operators. Brute strength and cutting-edge engineering define the core of these mechanical structures. One can notice how the steel frame of such a truck remains rigid even under a load of 300 tons. These vehicles represent the physical manifestation of ambitious industrial objectives. The process of hauling unbelievable weight across deep quarries is only gaining momentum. It seems simple to just increase the size of a vehicle, but in reality, every meter of height requires a complete redesign of the transmission and cooling systems. The equipment gradually maneuvers through narrow excavation paths with jewelry-like precision, but this is just the beginning. Each machine in this category surpasses the previous one in technical specifications and lifting capacity. The final unit in this specialized lineup represents a level of power that challenges traditional perceptions of land transport. These trucks did not merely change the global mining and construction industries. The physical dimensions of the chassis and the diameter of the tires are only the starting point for their operational capabilities. Transition to the next level of heavy machinery reveals even more complex engineering solutions. Thus, the introductory phase of understanding these giants concludes, opening the way to a detailed analysis of their internal systems. 3,300 horsepower represents the massive output generated by the most audacious mining vehicle ever engineered. Why did the Trax division of General Motors in Canada launch the single unit known as the 3319 Titan in 1973? A single truck of this magnitude was designed with the clear mission to dominate heavy mining operations by performing the labor of an entire traditional fleet. But this ambitious goal was met by only one physical machine ever constructed in history. It remains a singular legacy of mechanical engineering. The engine compartment housed a Detroit diesel 16V149 power plant, featuring 16 cylinders in a V configuration. This massive reciprocating engine worked in tandem with a General Electric gas turbine to provide the necessary propulsion. It is visible how this combined system allowed the vehicle to haul 350 tons of rock, even across steep inclines and fractured rough terrain. One can notice the immense scale of the engine displacement, which reached approximately 169 liters. But this is just the beginning. Everything only gets more complicated when analyzing the drivetrain. An electric transmission paired with an automatic gearbox directed power to the rear wheels via onboard generators. This configuration ensured continuous torque and smooth operation even under the most extreme mining loads. The heavy-duty hydraulic suspension and the rear-wheel drive setup were engineered for maximum stability and shock absorption in the harshest environments. Because the mining terrain is unforgiving, these systems prevented the massive frame from succumbing to the vibrations of the road. 66 feet of total length made the Titan a visually jaw-dropping presence in the Canadian quarries. Standing over 24 feet tall, the vehicle weighed more than 600 tons when its bed was fully loaded with ore. At first glance, its movement might seem sluggish, but in reality, the truck could reach speeds of 35 miles per hour while carrying its full weight. One can notice how the dust settles slowly as the giant tires leave deep impressions in the earth. The sound produced by the machine was unforgettable, blending a deep 16-cylinder rumble with the high-pitched whine of the gas turbine. Accessing the driver's cab required climbing external stairs, as the operating station sat high off the ground. Piloting the vehicle felt like steering a moving wall through the industrial landscape of the mine. After over a decade of active service in a Canadian mine, the unit was retired from production. It is now on display in Sparwood, British Columbia, serving as a proud local landmark. The process of mining continues to evolve with even larger machinery. Transition to the next level. Another vehicle exists that bears a closer resemblance to a land train than a traditional heavy truck. 560 feet is the total length reached by this articulated convoy, which visually resembles a land-based train more than a standard transport vehicle. Why did the United States Army commission such a massive machine in the 1950s? The military required a platform capable of traversing vast, remote regions where neither paved roads nor railway lines existed. This challenge resulted in the creation of the LeTourneau TC-497 Mark II, also known as the Overland Train Mark II. It only looks obvious that a vehicle this this size would be a single unit, but in reality, it functioned as a wheeled locomotive pulling a long series of specialized trailers. This mechanical beast relied on 4 Detroit diesel engines to generate its massive power. Each individual engine produced 1,170 horsepower, resulting in a combined total output of 4,680 horsepower. These units were configured with 16 cylinders in a V-shape, all working in precise synchronization. But this is just the beginning. The engines functioned as generators to provide electricity for traction motors distributed throughout the entire length of the convoy. One can notice how the electric transmission and automatic gearbox managed the distribution of power to every module. While the maximum speed reached just under 20 miles per hour, the true strength of the machine lay in the immense torque it generated. This was essential for crossing difficult surfaces such as deep snow, loose sand, and frozen plains. It gets more complex further on. The independent suspension system was engineered specifically to maintain stability across wildly variable terrain, from shifting ice to coarse gravel. It is visible how the cab sits high above the ground, featuring a futuristic design that resembles an elevated command tower. This structure provided the crew with panoramic views of the horizon. The combined drone of the 16-cylinder engines created a continuous metallic soundtrack that echoed across the desolate landscapes of Alaska and Nevada during testing. At first glance, such a powerful machine seemed destined for success, but the rapid rise of air cargo transport eventually rendered the project obsolete. Consequently, the TC-497 Mark II never entered full-scale production despite its successful field trials. The vehicle remains one of the boldest examples of overland engineering ever realized. One of the original cabs was even repurposed by engineers for early NASA exploration vehicle concepts. Transition to the next level. 150 tons of heavy machinery often define the mining world, and the next subject is a Japanese Titan that continues to dominate industrial operations today. Its sheer scale and mechanical precision represent the pinnacle of modern earth-moving technology. The process of exploring these giants continues as the narrative shifts from historical prototypes to the active monsters of the modern quarry. 3,500 horsepower is the raw mechanical output generated by the 18-cylinder V-type Cummins QSK78 engine. Why is such extreme power necessary for a single mining vehicle? One might assume that standard mechanical transmissions could handle the load of a quarry, but in reality, the massive resistance of 363 metric tons of rock requires a specialized electric drive system to prevent transmission failure under strain. This engine functions as a primary power plant, fueling generators that send energy directly to the rear wheel motors. The Komatsu 980E stands as one of the most technologically advanced heavy haulers currently dominating the global mining landscape. It is visible how the Japanese engineered machine maneuvers through the most brutal environments found in the open pit mines of Australia, Canada, and South America. The equipment gradually climbs steep inclines of up to 10% while maintaining steady traction through its continuous current automatic transmission. This allows the truck to reach a top speed of 40 miles per hour even when the bed is loaded to its maximum capacity of 400 short tons. But this is just the beginning. One can notice the sheer scale of the vehicle, which measures 51 feet in length and stands 24 feet from the ground to the top of the chassis. The 4 tires alone reach a diameter of nearly 13 feet, dwarfing the support vehicles moving nearby. Everything only gets more complicated when considering the structural protection of such a massive frame. A hydro-pneumatic suspension system controlled by electronic sensors adapts to every change in the broken terrain of the quarry. This protects both the operator and the metal structure from the violent vibration of hauling ore. Top-tier safety systems and onboard diagnostics operate within a climate-controlled cabin that functions more like the bridge of a massive cargo ship than a traditional truck. Satellite navigation systems allow the machine to maintain its course through dense dust and low visibility. It does not end at this stage. Automated sensors continuously transmit data via real-time remote monitoring, which was the first feature of its kind on a Komatsu heavy hauler. This system allows engineers located hundreds of miles away from the site to detect part wear or performance fluctuations before a breakdown occurs. The modular design of the truck ensures that maintenance remains fast and straightforward even during around-the-clock operations. Because any minute of downtime results in significant production losses, the 980E is engineered for constant shifts. One can notice how the electronic traction optimization keeps the rear-wheel drive giant stable on slippery or uneven surfaces. The process of hauling remains efficient as the machine moves with surgical precision despite its 363 metric ton payload. The material is ready to move to the next processing phase without haste. 4,600 horsepower is the total output generated by the massive power plant of the BelAZ 75,710. Launched in 2013 and manufactured in Belarus, this vehicle remains a living legend within the global mining industry. Engineered with the singular mission of hauling the heaviest possible payload in a single trip, this machine holds the record as the heaviest haul truck currently in active service. Why is such immense power required for a single vehicle? One might assume a standard industrial engine would suffice for transport, but to move hundreds of tons across vertical inclines, the truck requires a configuration that exceeds the capabilities of any conventional terrestrial transport. The propulsion system consists of two separate MTU-DD 16V4000 diesel engines. Each individual engine delivers 2,300 horsepower, combining to create enough torque to physically move literal mountains of rock and ore. One can notice how the immense energy from these engines is converted into motion through an advanced electric drive system. It seems simple to just use a mechanical transmission, but in reality, the scale of this truck makes such a system impossible. The engines generate power to run specialized electric motors mounted at each axle, providing constant torque and uniform traction. But this is just the beginning. The truck utilizes an 8x8 drive configuration, where all 8 wheels receive power simultaneously. This mechanical synchronization helps the vehicle remain stable even when navigating uneven or steep terrain in deep open pit mines. It is visible how the hydropneumatic suspension automatically adjusts both height and stiffness to adapt to the immense weight of the cargo. Of 40 miles per hour, over 67 of 40 miles per hour, over 67 feet in length, 26.5 feet in height, and nearly 32 feet in width, the machine dominates any landscape it enters. The process is only gaining momentum as the operator manages this mass from a fully climate-controlled cab. Inside the command center, onboard diagnostic systems work alongside traction control and load monitoring software. Multiple cameras and sensors are positioned around the chassis to offer the operator full situational awareness of the surrounding environment. Currently, these machines operate in the coal and iron mines of Siberia and Kazakhstan, enduring extreme cold and harsh working conditions that would compromise lesser equipment. Transition to the next level of maintenance reveals even more complexity. Replacing just one tire requires the use of a custom-built crane due to the sheer size and weight of the rubber components. This is not the limit of its operational requirements, as every part is scaled to the extreme. The massive frame and its integrated systems ensure that the flow of raw materials continues without interruption in the world's most demanding environments. Thus, the technical parameters of this heavy hauler define the limits of modern industrial engineering. The machine concludes its cycle and prepares for the next load. 3,000 horsepower is the total output generated by the hybrid power plant of the ETF MT240. Why does this machine abandon the traditional mechanical drivetrain found in standard mining vehicles? It only looks obvious to use a single large engine and transmission, but in reality, this truck utilizes diesel-powered generators to feed independent electric motors located on every single wheel. This specific technical configuration ensures a permanent all-wheel drive system where torque distribution is managed individually for each point of contact, providing unparalleled control when moving massive volumes of rock. The process is only gaining momentum. An intelligent electronic system manages the fully automatic transmission, continuously adjusting the delivery of power based on the specific load weight and the resistance of the terrain. One can notice how the active hydropneumatic suspension reacts in real time to shifting weights and uneven road surfaces, keeping the chassis perfectly level. The architecture is strictly modular, allowing the drivetrain to be configured from an 8x8 layout to a 10x10 or even larger, depending on the specific requirements of the mining site. It seems simple to design a truck for durability, but the MT240 is engineered to operate for over 25,000 hours before any major structural maintenance is required. The equipment gradually demonstrates its resilience through a unique redundancy feature where the truck remains operational even if one or two wheel units experience a complete malfunction. Such a capability is virtually unheard of in heavy industry, where a single mechanical failure typically results in immediate downtime. The camera glides along the centrally located cabin, which provides the operator with full 360-degree visibility. Inside the cockpit, the interface consists entirely of digital touchscreen panels, real-time diagnostic systems, and integrated proximity sensors. Because the ride is kept stable and smooth even under a full load, the physical demand on the driver is significantly reduced, which directly increases overall operational efficiency. Everything only gets more complicated when considering its autonomous capabilities. Without traditional axles, the machine possesses a clean clean, modular aesthetic that serves a functional purpose in enhancing off-road performance and simplifying maintenance access. It has already undergone rigorous testing in fully autonomous environments, where it is operated remotely from command centers located many miles away from the actual work zone. This level of integration marks the machine as one of the most advanced haul trucks currently existing on Earth. The truck moves with a steady, calculated pace across the quarry floor, as the electric motors hum with constant frequency. The material reaches the discharge point, and the cycle of the MT240 continues with high-precision movements. Thus ends the technical overview of one of the most sophisticated transport solutions in modern mining. 680 horsepower. This is the output of the 8-cylinder inline diesel engine developed by the German manufacturer for its LG 1750 model. Why does such a massive vehicle possess a power rating that seems modest compared to specialized heavy haulers? High speed and cargo delivery are not the objectives here. This unit functions as a mobile lifting platform, where every kilowatt of energy is redirected toward maintaining absolute stability during the elevation of 750 metric tons. The automatic transmission is fine-tuned specifically for slow, controlled movements. One can notice how the chassis shifts with millimeter precision when the operator engages the drive. This allows the crane to position its massive frame exactly where the center of gravity requires it to be. The equipment gradually stabilizes itself using an 8x8 drive system integrated with directional axles and a complex hydraulic suspension. Leveling the base is critical for the safety of the entire lifting operation. But this is just the beginning. The highlight of the machine is its massive telescopic boom. When fully extended with additional sections, it reaches a height of 643 feet. This is roughly the size of a 60-story building towering over the landscape. It is visible how the steel sections slide out with the hiss of powerful hydraulics, dominating the horizon of any industrial zone. Everything only gets more complicated within the elevated operator cab. The interior is spacious and packed with computerized lift management systems. The operator utilizes joystick controls, while load sensors provide real-time data on the stresses acting upon the boom. This technology prevents any deviation from the calculated safety parameters during a lift. One can notice that the truck is transported in separate modules rather than as a single unit. Because of its extreme dimensions, the machine is disassembled into sections and reassembled directly at the job site. This modularity allows the crane to travel between projects more easily, providing a level of versatility that stationary tower cranes cannot match. It does not end at this stage. Industrial sectors such as nuclear reactor maintenance, stadium construction, and bridge assembly rely on this mobility to save weeks of labor. In one specific instance, the LG 1750 was used to install a 500-ton bridge section in only 6 hours. This efficiency cut several days off the original construction schedule. Transition to the next level. The machine proves its worth by moving between sites, allowing for rapid deployment and wind turbine installation where every hour of downtime is costly. Large-scale infrastructure projects are completed faster because the crane can be repositioned as soon as a single task is finished. The molten stream of logistics flows more smoothly with such adaptable heavy equipment. Thus, the crane reaches the standard of performance required for the world's most demanding engineering challenges. The lifting cycle concludes and the components are prepared for their next deployment. 2,000 horsepower is the output generated by the massive 16-cylinder Caterpillar engine powering the Crest coal hauler. Why is such immense force packed into a machine that is not the tallest in its class? The sheer power is not intended for speed, but for the mechanical necessity of moving 270 tons of coal in a single trip across industrial landscapes. This specialized heavy-duty truck, manufactured in the United States by the Crest Corporation, prioritizes a low center of gravity and a wide footprint over vertical height. But this is just the beginning. Engineers at the Crest Corporation designed the drivetrain with reinforced components specifically to manage the steep grades found at coal processing facilities. One can notice how the automatic transmission shifts precisely to manage the high torque required during short and high-intensity hauling runs. It only looks obvious that a rear-wheel drive system would suffice, but in reality, the entire assembly is strengthened to prevent failure under the stress of massive payloads. The equipment gradually moves across uneven surfaces while the articulated suspension absorbs the constant vibration and mechanical shock. The process is only gaining momentum as the truck reaches the unloading zone. It is visible how the signature curved rear dump body facilitates a smooth dumping angle, which serves to improve both load control and operational safety. This unique geometry allows for the fast and precise discharge of materials, which effectively minimizes delays during continuous cycles of operation. acceleration. Everything only gets more complicated when the environment shifts. Because these machines are often tasked with shuttling coal between storage yards and furnaces at thermal power plants, visibility is a critical technical requirement. The spacious cab is outfitted with panoramic windows and ergonomic controls that allow the operator to manage the massive width of the vehicle with jewelry-like precision. At first glance, the task is a simple transport loop, but in reality, the maneuverability in tight industrial spaces is what defines the efficiency of the haul. Modified versions of the crest hauler are sometimes adapted for the transport of molten steel slag by adding specialized thermal shielding to the chassis. It does not end at this stage, as the operational demands in several United States industrial sites require these machines to run virtually 24 hours a day. Transition to the next level involves streamlined pit stop maintenance and rapid operator shifts to ensure the wheels never stop turning. One can notice the dust settling briefly during these transitions before the 16-cylinder engine restarts its cycle. Hundreds of tons of material are moved daily by these specialized haulers to keep the power plants and mills functioning at peak capacity. Now, the narrative shifts from the optimized efficiency of modern coal hauling to a legendary machine built specifically for the challenges of the desert. These American-built trucks conclude their current shift, leaving the industrial yards ready for the next phase of heavy transport. 100 tons is the staggering weight the BelAZ T100 could haul across the shifting dunes of the Sahara Desert. Why did the French manufacturer BelAZ undertake such an ambitious engineering project in the late 1950s? It would seem a standard heavy vehicle could manage industrial transport, but the extreme heat and unstable terrain of North Africa rendered conventional trucks useless. Consequently, the company developed a machine specifically designed to survive the most unforgiving environments on the planet. The process is only gaining momentum. 29.6 liters of displacement defined the massive Cummins V12 diesel engine powering this mechanical giant. While its output of 600 horsepower might appear modest by contemporary industrial standards, it was entirely unmatched during its era of operation. This immense power plant generated the monstrous torque required to move massive loads through deep, fine sand. One can notice how the 6x6 drivetrain and a manual transmission with multiple low-range gears allowed the vehicle to maintain traction. It is visible how the tires, standing more than 7 feet in diameter, rotate slowly to conquer steep desert grades and isolated off-road routes. The equipment gradually reveals its true scale. At first glance, the vehicle resembles a moving fortress rather than a standard transport truck. In reality, its dimensions were unprecedented, stretching to over 50 feet in length and reaching a height of nearly 16 feet. The suspension system relied on heavy-duty leaf springs complemented by dual shock absorbers at every wheel to stabilize the chassis on hot, unstable ground. The cab was engineered to seat 3 operators and featured reinforced insulation. This shielding was critical to protect the crew against the invasive desert sand, extreme ambient heat, and the constant vibration of the V12 engine. Everything only gets more complicated when considering the logistics of such a machine. Oil exploration operations across North Africa relied on these trucks to transport drilling equipment, massive fuel tanks, and prefabricated structural components. Large capacity fuel tanks were integrated into the design, allowing the T100 to travel hundreds of miles through the remote wilderness without the need for refueling stops. Only 4 units of this model were ever constructed, cementing its status as an incredibly rare and historic piece of heavy machinery. Today, one preserved example remains in Lyon, France, where it serves as a primary attraction for those studying industrial history. It only looks obvious that a truck of this size would be driven to its destination. Because no European road could accommodate the full width or weight of the vehicle, the very first T100 had to be completely disassembled and shipped in separate parts. This logistical hurdle highlights the extreme physical presence of a machine that exceeded all contemporary infrastructure limits. The transition to the next level of heavy transport took a different turn following the desert success of the French engineers. While this legend was built to master the burning sands, the next specialized vehicle was engineered to face the opposite extremes of ice, deep mud, and terrain where no other mechanical transport could possibly function. 1,500 horsepower is the output generated by the massive 12-cylinder turbo diesel engine at the heart of the Kama 7850. Why is such a colossal amount of energy required for a single transport platform? The engine does not drive the wheels directly, but instead powers a high-capacity generator that distributes energy to individual electric motors located on every axle. This sophisticated hybrid architecture ensures that constant torque is delivered to the 16x16 drive configuration, allowing the vehicle to maintain momentum even when ascending steep inclines or traversing unstable, shifting soils. The The equipment gradually adapts to the surface using an independent hydropneumatic suspension system. One can notice how each of the massive wheels adjusts its height and internal pressure independently based on the specific load and the resistance of the terrain. This mechanical flexibility keeps the heavy chassis perfectly balanced while crossing frozen forests or deep, muddy plains. It only looks obvious that a machine of this size would be difficult to handle, but in reality, the automatic transmission utilizes advanced electronic control systems to manage the distribution of power. But this is just the beginning. The camera glides along the low-profile and armored cabin of the vehicle, which shares a visual design language with space exploration crafts. Transition to the next level. While the maximum speed reaches approximately 43 miles per hour, the truck is specifically optimized for high-precision operations at lower velocities. Modern navigation and communication suites are integrated into the cockpit, enabling the platform to carry out autonomous missions or function via remote control in hazardous zones. The modular body architecture allows for total customization, transforming the unit from a rocket deployment system into a mobile scientific laboratory or a specialized logistics carrier. The process is only gaining momentum. It seems simple to transport heavy equipment across flat ground, but this machine has crossed vast distances without encountering a single mile of paved road. Because it can operate in sub-zero temperatures with total reliability, the truck is frequently deployed for large-scale emergency responses where aerial support is impossible. Specialist versions have been engineered for rescue operations in extreme environments where helicopters cannot land due to atmospheric instability. It is visible how the armored hull moves through terrain that would stop any conventional transport. Everything only gets more complicated. The Kama 7850 serves as a primary asset for military logistics and the tactical movement of heavy equipment. Yet even this mechanical giant represents only one solution for traversing the most unforgiving landscapes on the planet. The next machine does not rely on the rotation of massive wheels, but instead crawls across surfaces where no tire could ever maintain traction. Thus, the capabilities of wheeled heavy transport reach their peak, making way for a different method of locomotion. 710 horsepower is the output generated by the V12 turbo diesel engine of the BelAZ DT30PM. Why is such immense power necessary for a single transport vehicle? A standard engine would stall or seize in the environments this machine is built to conquer. This tracked articulated all-terrain transport vehicle, engineered in Russia, functions as a mobile survival platform rather than a conventional truck. The engine drives a hydromechanical automatic transmission that distributes torque across both sections of the articulated body. It is visible how the vehicle flexes at the central joint to adapt to extreme terrain shifts. This mechanical articulation ensures that all four track units maintain contact with the surface, whether crossing frozen tundra or deep swamps. One can notice how the massive rubber metal tracks replace traditional wheels to provide unmatched traction over mud, ice, snow, and open water. The suspension system, consisting of heavy-duty rollers and articulated arms, maintains structural stability on unstable ground. The process is only gaining momentum. Each track moves independently to prevent the vehicle from sinking into saturated soil or soft snow. 66,000 pounds is the empty weight of this machine, which extends to a total length of approximately 52 feet. Despite its mass, it can carry an additional payload of 66,000 pounds. The equipment gradually maneuvers through flooded landscapes with the ease of a specialized vessel. At first glance, the bulk seems unwieldy, but in reality, the weight is distributed so evenly that the ground pressure remains minimal. Temperatures as low as -58 degrees Fahrenheit do not affect the internal operations of the pressurized and heated cabin. It does not end at this stage. For the crew, everything only gets more for the crew. Everything only gets more complicated when the machine operates in total isolation. Military logistics, Arctic research, and rescue missions rely on the DT30PM to supply remote outposts where no roads exist. Some units are outfitted as mobile laboratories, while others serve as command centers or emergency shelters in the most remote polar regions. The equipment moves with a slow, relentless rhythm through the ice. It gets more complex further on. 100% of the team's needs were met by a single DT30PM during a famous scientific expedition in the Arctic. The researchers lived, worked, and communicated entirely from within the vehicle for several weeks without any outside support. One can notice the frost accumulating on the exterior while the interior remains a stable environment for delicate electronics. This demonstrates that the machine is a self-sustaining base capable of operating where no other mechanical system could survive. The vehicle continues its path through the deep snow, completing its transition across the uninhabited wasteland. From here, the mission proceeds according to the planned route as the steel tracks grip the frozen earth. Thus ends the overview of one of the most capable transport platforms in existence. 100% of these vehicles represent a radical departure from standard mechanical design, having successfully overcome the constraints of gravity, extreme climates, and difficult terrain. Why did engineers create such massive structures that seem to defy conventional logic? The necessity for these machines arose from the unique demands of global mining, deep field exploration, heavy logistics, and the most rigorous defense requirements. Every individual unit serves as a physical testament to human engineering and acts as a bold response to the harshest environmental challenges on the planet. The process of constructing these giants is only gaining momentum as new materials are introduced. One can notice how the immense frames of these machines support weights measured in the hundreds of tons while maintaining structural integrity. It only looks obvious that such power is required for modern industry, but in reality, the precision of their hydraulic systems and the scale of their power plants represent the absolute peak of modern mechanical achievement. These machines exist as functional realities rather than conceptual designs, performing daily tasks that were considered impossible for heavy equipment just a few decades ago. The mechanical evolution of these vehicles continues to reach the next level of complexity. One can notice how the metal plates and reinforced chassis lay in even layers, forming the backbone of the most extreme transport systems ever devised. These technical marvels fulfill their designated roles in the production chain, ensuring that materials and equipment reach their final destinations across the most inhospitable regions of the globe. Thus, the material reaches the standard ready for the further stage of industrial operations. The machine is ready to move to the next processing phase without haste.